Welcome friends, welcome to Code.py. Today we are going to look into another very popular and exciting AI and machine learning based Python project, that is a chatbot. Now, in general speaking, what is a chatbot? A chatbot is an intelligent piece of software that is capable of communicating and performing actions similar to a human being. Chatbots they are basically used a lot in customer interactions, marketing and social media sites, etc. And also with some of the instant messaging clients. Okay, now the way to design or develop a chatbot basically consists of two approaches. One is a retrieval based system or a generative system. So a retrieval based system or model, it basically consists of using predefined input patterns and responses, and then it uses some sort of heuristic approach to select the appropriate response. Now, it is widely used in the industry where to make goal-oriented chatbots where we can customize the tone and flow of chatbots to drive our customers with the experience they need. So, in other words, areas where the scope of the data or the scope of the knowledge base needed for the chatbot is limited, or it's very concentrated to or very directed to a particular area, that's when it is really useful. The other category is a generative based chatbots. These are fairly complex as compared to retrieval based chatbots, and they are not dependent on any kind of predefined response or anything. These chatbots, they use really complex deep neural network based algorithms, and need a fair amount of processing as well as complexity to be developed through the code. So we are not going to focus on the generative based chatbot. Rather, we will be keep the things simple. We'll be designing a chatbot that will be a retrieval based chatbot. It will be trained on a limited data set, and we are going to use a special recurrent neural network, LSTM, and we will try to identify the category to which the user message belongs to and respond accordingly. Okay, now for this project, what I would need is somebody who is trying to gain knowledge out of it, or somebody who wants to use this. They should have some background with NLTK, Keras or Python. If you are not familiar with these areas, I would strongly suggest you to go through the details and try to study a bit around these topics, because I'm not going to cover any of the specifics or in-depth details of the code that I'm trying to write for this application. So yeah, without getting into like more details, let's get straight away into the coding. So the first thing we need is there is supposed to be a model that we are going to first of all develop, and for that I'll create a training chatbot file. So let's create a code file named training the chatbot. And in here we'll write the code which will be building our model, training the chatbots, and also we will, whatever model we'll be creating, we'll pickle the model file so that we can reuse it, or kind of we basically use that model to make predictions again and again. We are not going to build a model every time, so that's the reason for it. So let's write the code. Okay, so import NLTK from NLTK.stem. So we are going to use WordNet lematizer. And let's create an object. So lematizer is equal to WordNet lematizer. We can also create this object at a later point. So let's import the other packages that we need. So import JSON, because our training set is a JSON file, so we'll need it here, and import pickle, because like I said, we will be pickling the model file that is created and save it. And also we need NumPy as NP. We will need Keras. From Keras we are going to use sequential model from sequential. Okay, from keras.layers. import tense deviation dropout from Keras dot optimizers. From layers we have dense, activation and dropout. These are the neural network layers that we are going to use, and the optimizers we will be using the stochastic gradient descent. So import SGD, and then we will also need import random, basically to randomize our training and testing sets. Now let's define some variables. Words is equal to blank, classes is equal to blank, documents, ignore words. So ignore words are some of the punctuations that are used. So question mark we need to ignore, and exclamation also we need to ignore, and data file. Let's create the data file. Open /data intents.json. So this is the file that we are going to read, intents.json, and we are, like I said, we are going to read it. Now let's see what this file looks like. So this file is actually the source. Now if you see here, this is a dictionary, or it's a JSON document with the key intents containing a list of the different types of tags, and for each of these tags they are kind of different scenario or situation. For example, tag related to greeting, it has a pattern which follows something like this. If anything of the words like these, hi there, how are you, is anyone there, etc., is being spoken, so it indicates that it's about it's basically somebody who's trying to greet or greet the chatbot. So the response will be something from this defined set of elements. It will be a random response out of any of these. Similarly, we have similar responses for goodbye. Each has a tag, each has a pattern to identify, and then correspondingly a random response that will get generated. So this is like a sample data set or a data that I have created or that we are going to use, and of course there can be a lot of implications and a lot of use cases where not only just a response is needed, but also based on specific queries. We may have a response catered to a specific query. For example, if somebody who's asking for, let's say, information about Medicare or information about hospitals, then they have a follow-up question. They can have a follow-up question wherein they want details about a specific hospital, something like that. So that's an advanced level step. Probably I'll create another videos on this similar concept and similar project, and we will enhance the project at that point of time. So for now, simple thing to understand is we have this data set, we have this database in form of a JSON file which follows this structure that I just explained. So let's use this, and then we are going to create the intents variable, which will be defined, which will load all the data from this JSON file. So JSON dot loads file. Okay, next we are going to, and of course we have this lematizer variable word that we have used, and pre-processing the data, tokenizing using NLTK. So this is what we are going to do. We are going to pre-process the data, and we will be tokenizing it using NLTK. So how to do that? Let's do it for intent and intents. For intent and intents, within which we have the intents. So basically in this intent file, if you see, intents is the parent key. So for each of these elements in this list, what we are going to do, we are going to identify patterns. So for pattern and intent, for each intent we have a pattern, and for each of these we'll tokenize the words. Tokenize each word. Okay, so word is equal to NLTK word tokenize in pattern, and words dot extend word. Okay, then add documents in the corpus. That's the next step. Documents dot append word, documents dot append word intent. And we'll add these tags to basically we'll add these tags which are identified to our class list. So add to the classes list. So for that, if intent tag not in classes, it's going to be classes dot append intent. Okay, yeah, so basically this will give us our words, our documents, and our classes. Now we will next we will lemmatize each word and remove the duplicates. So words lemmatizer dot lematize word dot lower. Okay, for a word in words if word not in ignore word not in. So basically we have to ignore these punctuations, that is question mark and exclamation. Everything else we need to lemmatize. Okay, so finally words will be let's create a unique list or sorted list from this. So words sorted list from the set that we have identified. Okay, so this will give us the list of sorted, and also similarly we'll sort the classes. Okay, then after doing this, let's print and identify whatever we are doing, is it producing the expected result or not. So print the words, classes, and document counts. Okay, now what are these? Each of these documents is a combination between patterns and intents. Classes is actual intents, and the words, all words and vocabularies. All words that consist of the vocabulary. Okay, so let's print them and identify. So print count of documents. Let's print the count for. Okay, so this is one, and then second we will print the count of classes. Third, we will print the unique lemmatized words. Okay, words. Okay, pickle. Yeah. So before we actually pickle the file, let's print out and see what we are trying to achieve, or identifying the documents, classes, and lemmatized word, is it working or not. So let me execute this. So for that we'll say file3 training. Training the chatbot. Okay, so we are in the source, so it should be okay. cd product slash product. So we are in cd learning chatbot as source Python 3 training source YAML source. Okay. Python 3 training the chatbot. Okay, let's execute this and let's see what happens. So you will get this particular warning, but it is fine. The reason for that is because I am not using any GPUs for this on this machine for this program. Okay, so we have got an error which says file not found. Let's see why it is. So okay, because of this spelling mistake. So let's fix this and let me re-execute. Okay, another mistake. It's fine. 54. Okay, let's re-execute it again. Okay, so this time it has executed, and as you can see, we have got the count of documents, we have got the count of classes, and we have got the count of unique lemmatized words. So the next step is we will be pickling this and then we will train our model and generate the model. Okay, so let's pickle these files. So for that I'll be using this file. So pickle the words, classes, so we are going to dump words in a file in the out directory. So dot slash out slash words.pkl, which will be a binary write. We will be also pickling the classes into the classes. Classes. Okay, so these two files, and then we will be training the model. Okay. The training data. Okay. We get an empty array for output. Output empty equals 0. Now we'll create an empty output array which will be the length of exactly of that of the classes that we have. So length of classes training. Now let's create training set, a bag of words for each sentence. Training set bag of words for each sentence. So for that, for doc in documents, initialize our bag of words, bag equal to this, and then list of tokenized words for each pattern. That's what we will create. List of for the pattern word is equal to doc 0. Okay, then let's lematize each word and create a base word in attempt to represent the related word. Okay, so pattern words equal to lematizer lematize word of lower. Okay, for in pattern words. Next, we create a bag of words array with 1 if the word match is found, and otherwise a 0. So basically we'll create a bag of words array with value 1 if there is a match in the current pattern, else 0. Okay, so for word in words, we will append 1 bag dot append a 1 if word in pattern words, else append 0, and output is going to be so let's capture the output row. Output for the row, we first create a list out of the empty output that we had defined earlier, and the output row we will pass or define the classes index to capture 1, classes so output is always going to be 1 for the current tag. That's what we are trying to do here. Otherwise by default it will be 0, because the way output empty has been initialized here, if you can see, everything is 0 except wherever we are updating it for each of these classes. Okay, let's append this to the training set. So training dot, we'll append combination of bag and output row. So this should give us our training set. Now we will shuffle our features, and so basically now we will be shuffling this training set to segregate it into a training set and a testing set. So let's do that. So we will shuffle our features and turn it into an array. So for that we'll use random. And then we'll create a training and test set. Where X is basically the patterns and Y are the intents. So how to do that? So for the train X, we will say list from the training data that we have got. We will choose everything on the 0th position. This will give us the training data for X and okay, so this is the, now let's, at this point let's print it out that we have created the training data. And we should be good with this. So now next we will create the actual model. So this will be an LSTM, a neural network based model, which will have 3 layers. The first layer will be of 128 neurons. The second layer will be another layer of 64 neurons, which will contain the, which will be, both of these layers will have an activation function value, and the output or the final layer will be having the number of basically the output neurons equivalent to the number of classes that we want to classify, and we'll be using the softmax activation function for that. So let's create it out. So create the model, which will be, like I said, 3 layer. These notes or the comments that I'm adding, these will be really useful for somebody who is going through this code later on. So that's the reason I keep on adding comments like these. So like I said, the output layer contains the number of neurons equal to the number of intents to predict the output, with softmax of course as the activation function. So let's define the model. So model is equal to, we will be using the sequential model that we have imported from Keras. So then model add a dense function with 120 dense layer with 128 neurons and input shape, which will be equal to the length of the X-train, the training set elements. And nothing to follow here, and this will be activation will be, like I said, value, and then we'll also add a dropout of 0.5. Copy this to create another layer, and that layer will be 64. Before the input it will be getting is from the previous, and I think there is an equal to which is missing here, input shape, and the output for this one is the previous layer, so no need to specify this, and the activation function will still keep as value. Again introduce a dropout of 0.5, and let's create the final layer, which will be not 64 but length of 0th element, and activation function instead of value will be softmax. So this will create our model. Now let's compile the model. We'll be using SGD, that is stochastic gradient descent with Nesterov accelerated gradient, to compile the model. So for that, let's define SGD is equal to SGD. The LR value will be 0.01. Yeah. TK will be equal to 1 exponential of -6. Momentum is to be kept as 0.9, and value has to be 2. Okay, now the dot compile. Loss function to use is categorical cross entropy. Optimizer, as we said, is SGD, and matrix that we are looking for is going to be accuracy for now. Okay, so this will be compiling the model, and then post that we will be fitting and saving the model. Fitting the model, we'll be using training set X and training set Y. We'll be using epochs. 200, batch size of 5, verbose. Verbose will set to 1, and we'll save the model. Again to the out folder, call it chatbot model.5 and pass the details, paste, and once this is saved, we'll confirm by printing on the screen that the model has been created. Okay, so let's execute this code and see if our model is getting created successfully or not. So I'll save this file and I will execute the code again. Let's wait. Okay, it's throwing an error. Throwing an error in line number 105. 105, let's see what is the error. 05, LR is 0.01, DK is 1, e to the power 6, momentum is CDLR 0.01. DK is DECAY, momentum. Okay, there is a spelling mistake. Okay, momentum is 0.9, MOD is true. Okay, so So let's save it again and execute. And if everything goes fine, we will have the model created here. Argument compile. Okay. It's throwing an error this time in this loss optimizer. Okay. My apologies. Another spelling mistake. It's going to be matrix. Let's run it again. The model should get created in the out folder. Yeah, so I think this time it has gone to the epochs and the epochs are executing. So once the model is getting trained with all these iterations getting completed, the model file should get created here. Yeah, so now the model has got created. We have successfully implemented the model. Now the next step is we need to use this model, the trained model, to the actual application, which will be a GUI based application. So I'll be creating a second part of this video where I'll be developing that GUI application, and we will be using this model to play around and see how this model behaves, or how we can create the chatbot. Okay, so I'll be coming up with the second part very soon. If you like this video, kindly consider subscribing and sharing. And thanks a lot for watching, and you guys have a great day. Thank you. Thanks a lot.